Hello everyone, my name is Birjesh Kumar and I am in Data Science and Business Analytics intern at the Spark Foundation. This is my first task, which is prediction by using the supervised machine learning. So in this task, we have to predict the percentage score of the student based on the hour and he and she study. So we have two variable, number of hours study and the score that he she got in the exam. So uh, I am going to import the all required library for analysis, importing Panda as a PD, importing NumPy as a NP, importing Matplotlib as a PLT, importing Shibon as a SNS. After that, we load the dataset uh, pd.read Excel and the file path we have given, and data is provided by the Spark Foundation. Now let's export the data. df.shape give the number of row and the number of column, and to visualize the data head, df.head, we want to see the 5 row 5 record, and df.tail to get the uh, 5 last record of the data. To check the null value presence in the data, df.isNull.sum, and here we can see 0 number of null value in our column, 0 number of null value in score column. df.info, basically it is used to get the data type of the each column and the non-null value, and how much memory it consume, it tell. df.describe basically used to get the descriptive statistics of the data, and here we can see that mean of the hour and the score, standard deviation of the hour and score, and it gives the maximum minimum value of the hour and score, and here we also get the first quartile, second quartile and third quartile of the data. To find the relation between number of hours a student study and the score of a student, we have plot the scatter plot, or from above a scatter plot we can clearly see that number of study hour increase, the student score also increase, and also we can see these are positive correlated to each other. To verify it and to find the coefficient of correlation, coefficient, df.correlation method is Spearman, and the df.correlation method Pearson. We have find the coefficient of correlation 0.97, which means that 90% of the variability of the score can be explained by the hour and vice versa. Here we have plot the distribution plot of the hour, and we can clearly see that the student study hour basically spread about 1 to 9 hour. A maximum student study around 3 to 4 hour. Similarly, we have plot the scatter plot, distribution plot for the score, and score of the student spread between 20 to 95 around, and the maximum student data score between 30 to 60. Separating the dependent feature and independent feature, we have assigned the y df dot column hour x is equal to 1. Basically in data, from the data frame we drop the hour column After that, we are splitting the data into train, test, and 20% data is the training data, and the sorry, 80% data is the training data, and 20% data is the testing data. Uh, After that, we importing the linear regression model and the training the model. So basically, in linear regression, basically, scikit-learn internally do it find the line, slope, and the intercept of the line where all maximum point fall. After seeing the scatter plot of the data, we cannot there cannot be any line where all the point fall. So that scikit-learn does it find the line in which difference of the predicted value of the line and the actual value of the point is minimum. So basically what we have to do, sum of the difference of the predicted value and the actual value of the score should be minimum. This create a optimization problem that scikit-learn solve internally. There is a two output of the model, a scope of the line and the intercept of the line. With the help of these value, we can visualize the linear regression line that best fit to the data. Equation of the line is mx equal to c, mx plus c, where slope of the line we get reg dot coefficient and the intercept of the line reg dot intercept, and we plot the L equal to mx plus c, and we plot the scatter plot, and we plot the line plot. Here we can see the best fitted line. The score prediction will be equal to reg dot predict x test, and we predict the score with the help of the x data by using the model training model, and also we will make the data frame where actual study hour, actual value, and the predicted score here we can get. And here we can see that uh, predicted score is very near to the actual value, and here we plot the distribution plot of the predicted value minus actual value, or here we can see their difference. Basically it's symmetrically distributed, and the range error of range lie between minus 5 to 7, and most lie uh, around 3 to 4. It's good for the model. For model evaluation, here we have two performance metrics for the model evaluation. First is the mean absolute error, and second is the R square. So we are get of the high R square and the less mean absolute error, that is good for the model. And mean absolute error we get 4.1, that is very less, and R square value we got 0.90. Basically R square value lie between 0 to 1, so it's 0.90, so it is a very high, it's good. Basically it imply that our model explain the 90% variability of the dataset. Now our main aim is to predict the score of student he or she study for 9.25 hour a day, and our model predicted the student score is 92.97%. So if a student study for 9.25 hour a day, then according to our model he she can score 92%.